Okay, here we go. Let's look at this one. Yes, go. Okay, 10 minutes or less. So we want to solve this linear system, right? Okay, so if we want to solve this using elimination, we have to line up the variables, right? That's one of our steps. If we go back, let me just delete. So I can go back and forth. Right. I have to line up the equations. That's my first step. So the x's and the y's and the numbers all have to line up vertically. So what did I do? Oh my goodness. There it is. There it is. We're good. We're good. Okay, so I got to get the x's and the y's to line up. So let's write this. It doesn't have to be in perfect standard form, but you just want the x's first, then the y's, then the constant. So what could I do to this top equation to make that happen?
Add 5y.
Everybody agree? Add 5y? If I add 5y to both sides, now we're getting to a point now where we can start to do some more of this stuff in our heads. So what am I going to get on the left side then?
5y plus.
Well, hold it. We want to do the x term first.
5x plus 5y equals 15.
Good. So the 5y we pushed over to that side, right? We get 5x plus 5y equals 15, right? Okay, what about the bottom equation?
Subtract 2x.
So I've got to push the 2x over here, right? I'm going to subtract 2x. So I'm going to get a negative 2x on that side.
Plus 8.
Subtract the 26 to that side. So the 8y stays there, doesn't it? I get negative 2x. Still got my 8y on the left side. And I've got a minus 26 over there. Everybody agree?
Yes, sir.
Okay. All right, so then now we got a linear system that we can deal with, right? So let me rewrite this real quickly. I'm on the clock, I know that.
I know
Be
the
quick.
next step. I know the next step, coach.
Okay, so next step here. Which variable am I probably going to want to get rid of here?
The x.
Everybody agree maybe the x's because the coefficients are a little bit smaller? Okay, so now somebody different, I want to know what am I going to multiply the top equation by? 2, right? That's good. If I multiply the top one by 2, what am I going to get if I distribute a 2 all the way through? 30, good, okay. So now we know, what do I have to multiply the bottom equation by? 5, very good. Oh man, you guys are getting this stuff, I love it. So that's gonna give me what? Negative 10x plus 40y, 5 times 8y would give me 40y equals,
Negative big number.
okay, well, break it into pieces. What's 5 times negative 20? 100. Negative 100. 5 times 6? 30 more, so negative 130, right?
Yeah.
Okay, so if I add these up vertically, then what do I get?
You take the 10.
Eliminate the x's, good. Okay, I get 50y equals negative 100, so y equals negative 2. Very good. We'll plug into either one of the original equations. Let's just pick, how about, doesn't matter, we'll just pick, how about that one? Okay.
Yeah.
So we get 8 times y, which is negative 2, plus 26 equals 2 times x. Okay? So that gives me negative 16 plus 26 equals 2x. That's just 10, isn't it?
Yes, sir.
So 10 equals 2x, so what does x equal?
5.
Very good. Okay, so now we get the solution. X equals 5, y equals negative 2, right? Okay, good. Now, you're going to hate that I'm about to do this to you, but I want to ask you here, could we have done this a little better?
Yeah, probably.
Is there a way, I mean, it worked, it was fine. I'm not saying that was bad, but is there a way we could have maybe done this, is there a way we could have done this maybe just a little bit better?
Other one.
Yeah.
The other one.
Absolutely.
Oh.
Okay, what could we have done to that blue system to make things a little easier? How about that? What if we divide the top equation by 5? Look at that. Okay, if I divide everything by 5, in the top equation, what am I gonna get?
X plus Y equals 3.
Oh, man, good. What about the bottom one?
I think by 2.
Divide by 2. And that's gonna give me negative X.
Plus 4Y equals negative 13.
Okay, now, we're not gonna go through the process, but wouldn't that have been easier?
Yeah.
Right?
Probably.
Okay. So just a, small thing, but that's something to look for, isn't it? We could always ask ourselves, could I simplify this system? Could I divide through by something is there a number that goes into all the coefficients, right? So we can make things a little bit easier, okay? All right, next issue, real quick. Setting up these applications. The assignments are very short. There's 2 assignments. 2.4 practice 1 deals with using Desmos to find intersections of lines. They're using technology. It deals with substitution, solving systems by substitution. 2.4 practice 2 is solving by elimination and a couple applications problems. Total of 6 problems on that one. They're short, right? But let's go through a couple of these. So I know these, everybody hates these, I get that, because they're just not, it's hard, they feel like work, right? I get that. But they're a reality, and so the better you get at them, the less they seem like work. So every once in a while, we're just gonna add some of these in, and by the end of the year, you're gonna be pros at this, right? So what do? Whenever we're solving something like this, always, if you're solving an algebra problem that's an application or a word problem, you wanna, what are the variables, right? We gotta define the variables. That's always your starting point, okay? So we read through this. Landon babysits and works part-time at the water park over the summer. 1 week he babysits for 3 hours. Babysits for 3 hours. Babysat for 3 hours and worked at the water park for 10 hours and made $109. Next week he babysat for 8 hours and worked at the water park for 12 hours and made $177. Now here, this is important, right? It's asking us here, how much does Landon make per hour at each job? Well, what are our unknowns?
She makes it.
Okay, good. So X is gonna equal hourly wage babysitting. And we'll just call it Y. What's Y gonna be then? Hourly wage for,
Ask the other, the water
at
park.
the,
Water park.
H2O.
I don't wanna write so much, right? Water park. Okay, so now we gotta come up with some equations. Okay, so let's look back at the information then. Now here's something else I want you guys to start thinking about. How many unknowns are there? 2, right? So then, this is called the fundamental theorem of algebra. We'll come back to this again and again. But I'm gonna need at least as many equations as I have unknowns to solve for both of those. So we're gonna need a system with 2 equations because I have 2 unknowns. So we gotta find information to create those 2 equations. Well, here's some information. 1 week he babysat for 3 hours and worked at the water park for 10 hours and made $109. So how can I make that into an equation? Where X is his hourly wage babysitting, right? So then if he babysat for 3 hours and he made X dollars per hour babysitting, how much money did he make babysitting? 3X, right? I'm gonna multiply the number of hours times the rate. $3 or X dollars per hour, right? X is the rate. So he's gonna get 3X dollars from babysitting. How much is he getting from the water park? He worked 10 hours. So what am I gonna multiply the 10 hours by to find out how much he made? Yeah, his hourly wage, which is Y, right? So plus 10Y equals, okay, and then what about this other statement then? Some other week, he babysat for 8 hours and worked at the water park for 12 hours and made $177. What's that gonna be?
8X.
8X.
Plus
12Y.
And we're not even gonna do it, but I mean, you could solve that system, right? Like, and probably what I'll even do
I think we should.
on the applications ones, I'll let you even use Desmos, so you can just graph the lines and look for the point of intersection, right? But I want you to be able to set them up as 2 things.
I think we should be able to
Okay.
do it.
Make sense? Okay? No, we're not gonna waste time on that. I'm running out of time. What about this one? What about this one? How much time I got?
You got like 10 seconds.
Oh, okay. Well, we'll do this tomorrow then. That's fair. You guys were good
Oh, come
sports.
on, man.
You were good sports. That's fine. I'll let you work.